because it's already time. So welcome. This is a workshop on artificial intelligence and intelligence architecture. So organized by Microsoft Learn Student Ambassador. This is what we'll be doing today. This is the overview. We do the introduction, very short introduction. Then we are going to have two presentations. Like for the first one, artificial intelligence. The second one, the intelligent system. So then we move to the joining the MLSA program, then the journey of a graduate MLSA. So the introduction, my name is Suleiman Adebayo. I'm an Alpha MLSA. I'm in Nigeria, but currently studying BTech in computer science and engineering in India. So my skills include machine learning, website design and development, digital marketing, among others. I'm having with me Usaifa, who is a beta MLSA, is from Iraq. So he's an IT student in the University of Suleimani. So his skills include the machine learning, mobile app development, computer architecture, graphic design, and the likes. And we're having our guest speaker, which is Sabia. So Sabia is a recent graduate of MLSA. She graduated as a Gold ambassador, and she's currently working as a junior developer at Jalub Group in the UAE. So let's quickly move to the first one, the business of the day, artificial intelligence. What do we mean by artificial intelligence? This is the creation of software that imitates human behavior. In what way? You know, on a normal day, we have certain set of tasks that literally requires human intelligence. For example, like a prescription of medicine for patients in the hospital, it literally requires human intelligence to do that. But we can train machines to do the same. Another one, we're having this autonomous vehicle which drives itself. It requires human intelligence to drive a car, like you have to learn how to drive a car, all those stuff. But training a computer system or a model to do that same task that typically requires human intelligence. So that's what we mean by artificial intelligence. So let's quickly check this out. This is a video by Microsoft itself. So it depicts what artificial intelligence is all about.
Artificial intelligence isn't coming, it's here. It's the defining technology of our time. But it's human ingenuity that makes it so powerful. Jane started losing her vision when she was 12.
California Street.
She uses Seeing AI.
I crept down the stairs.
I crept down the stairs and out the door,
which enables her to read and navigate her world. Microsoft AI is helping farmers adapt to climate change.
We can use technology to help feed the world without wrecking the planet.
Enabling wildlife conservation.
The ability to use AI really democratizes science. WildMe uses images from any source to help study endangered species.
And creating new ways for people with hearing loss to communicate.
I want the exact same information that my hearing friends have.
It's more than just imitating intelligence or sounding like a human. Microsoft AI is changing every industry, from healthcare.
And now you can see these finite details, the relationship with many structures.
To engineering. And telecommunications.
We are using artificial intelligence to change the way we are relating to customers.
AI lets us put people first.
The Microsoft tools really enabled us to breathe digital life into an iconic brand persona.
The product that we make is not a thing in a box.
No.
Microsoft AI empowers others to create experiences and potential. This is just the beginning.
Artificial intelligence, it's just opened up this whole world.
The future we invent is a choice we make.
That's a short introduction from Microsoft itself about the artificial intelligence. We all see what we can do, like we can apply AI in all the field, medicine, the finance, and the like. So this what it basically means. Now let's explore it further on our own after watching the video. Can you see the slide?
Yes, we
Can you
can.
see the slide? Okay. Okay.
I can't see any slide here.
Okay, you can see the slide. I think it's, but we all see the video clip about artificial intelligence from Microsoft herself.
I didn't see. Having it difficult to see the video.
Okay. So, okay, now let's move back to our slides. So we already know basically AI is just a system or a model that do the works that typically requires human intelligence to do, like prescribing medicine for patients, like driving cars, like unmanned aircraft, and the likes. Now, let's move to facts about AI. So we have basic fact about AI. The number one thing which I always call it like a misconception. Like people believe AI are dangerous. Like all those movies we watch, like AI will take over the world, all those stuff. No. AI is not dangerous, but it can be influenced by the human biasness. Like if the developer is biased, if the company that owns the AI model is biased, obviously their model, their system will be biased. Then we have other facts like AI. We have AI pets, like normal dogs, normal cats that people keep as pets. We have AI pet as well, which you can keep as pets. Obviously, it's not going to be eating or going to the toilet, but it's going to be like a normal pet. Most AI bots are female. Maybe we go to any commercial website, we want to place an order or the likes. When we see a bot that pump up, there is let me say more than 70% chances like the bot is going to be a female. I don't think I've ever seen up to 5 bots that is a male. I don't think so. So the AI recognizes emotion. Let's just clear this. Then AI can repair itself. AI has nationalities and passports. That may sound somehow, but that's the fact. We all know Sophia is a popular humanoid AI, humanoid robot. So she became full citizen of Saudi Arabia in 2017. So this is a picture of Sophia. So this is a real interview with Sophia. There's this YouTube link for the interview with Sophia. If you need the link, you can message me after the webinar. I will surely send you the link. So interview with Sophia. Sophia became full citizen of Saudi Arabia in 2017, and she's still doing well. But AI can do this, AI can do that, AI can do this, AI can do that. There should be certain guideline putting AI in place, like check and balance. That's why we have responsible AI in Microsoft. Let's explore responsible AI. What does that mean? AI is a powerful tool. Obviously, it can be used to greatly benefit human. We can use it to do a lot of things. But like other tools too, like other software, like other models, it must be used responsibly. So in Microsoft, the AI software development is guided by six principles. The first one among them is the fairness. The number one principle of a responsible AI is fairness. Fairness in what sense? The system should treat all people fairly. Like we have an AI system designed to approve a loan in a bank now. So the system should make prediction whether the loan should be approved or not without biasness in gender, ethnicity, or any other factors that may be disadvantage to specific set of people. So that's the fairness. So the system should treat everybody fairly. Reliability and safety. So the system should be reliable and should not cause harm to people. Obviously, those systems, they are here to help humans. They are here to make our life better. So they should not cause harm. The system should be consistent with design ideas. What it's asked to do, it should do it. For example, now, let's say we have a system to diagnose patient symptoms in the hospital. If those kind of system gave the wrong prediction, then it's going to endanger human life. Let's say we have a system now like autonomous vehicle or manned vehicle which drive itself on the road, or on the same road where we have cars that are being driven by a human being. So if those kind of system make wrong prediction or if they deviate from the design ideas, then it's going to cause catastrophe. So the system should be reliable and safe. The privacy and security. This is so important too because the AI system should be secure and respect privacy. The machine learning models, well, machine learning ML models, which forms basics of AI, in which AI system relies on. We are still coming to machine learning. The machine learning models which AI system relies on is based on a very large volume of data, which may contain personal data, obviously. So such data should be protected and should not be mismanaged. So the privacy and security should be given priority. Another features, the fourth one we have to go after this, is inclusiveness. The AI system should empower everyone and engage people. So it should bring benefits to all parts of the society, regardless of the physical ability, the gender, the sexual orientation, ethnicity, among others. So it should be like AI for everyone. It should not be like kind of putting some certain set of people in certain category which may be unfavorable. So the inclusiveness should be there. The fifth one of the sixth principle of responsible artificial intelligence is transparency. The AI system should be understandable. The users of this AI should know the system they want to use. What is the system going to offer? What is the limitations? What can the system do? What can't it do? So these things should be clearly stated. There should not be any set of ambiguity in the system. And the final point for this responsible AI is accountability. People should be accountable for AI systems. Obviously, it's a machine, so people should be accountable for it. Designers and developers of AI-based systems should work within a framework of government and organizational principles to employ that to ensure they deploy the solutions that will meet the ethical and legal standards that are clearly defined. So the system should not go against the government laws. It should not go against societal laws. It should not cause any harm. So it should be accountability. So these are the 6 principles of artificial intelligence. Now let's move to AI key elements. We have 5 key elements as defined by Microsoft herself. We have 5 key elements of artificial intelligence. The first one is machine learning. We have the anomaly detection. We have computer vision. We have NLP, natural language processing. Then the 5th one, the conversational AI. So let's take it one after the other. The machine learning. What is this machine learning? Machine learning, this machine able to learn. So machine learning is the foundation of AI systems. So it's basically the way we teach a computer to make predictions and draw conclusions from data. Let's check these GIF images. It's actually explaining the full concept of AI to us. What is happening here? A team of botanists and data scientists, obviously the AI engineer or data scientists, they are going to work with professionals in that field to make the model. So here they are collecting the flower sample. So the team of botanists and computer scientists, they collect samples of wildflowers. That's the first one. Then the second one, what will they do? They put labels. Okay, this flower is this flower is this. They label each flower. After they label each flower for number 2, then the number 3, the label is processed using certain set of algorithms to find the relationship between the features of the samples and the label species. So after they process the label data, then the result of the algorithm is encapsulated in a model. So they have to train the model. Then after training the model is now ready to go. Then next time they show the model any flower, the model will be able to say, okay, this is the name of the flower. So this is the basics of machine learning. That's how it works. You give certain set of data to train the model. After training the model, when you show something that is related to what you've trained the model with, even if it's not part, then the model will be able to know that, okay, this is the name of this thing, this is the name of this thing, based on what it has seen before. Going a little bit technical, for today session, we are not going for any coding or any technical because we're having diversified set of audience. So, but going further, we can see machine learning is techniques that uses mathematics and statistics. That's the basics of machine learning, mathematics and statistics, to create a model that can predict unknown values. You supply set of values, then the machine will be able to predict the unknown values. So this is machine learning. The number 1 key element of AI out of the 5. The second one, okay, before we go to the second one, this is the branches of machine learning. As I said earlier, I will not be going too deep on this. The next event we will be having, which will be only for professionals, then we'll be able to go further about this supervised learning, the unsupervised learning, and the likes. So the second one, the anomaly detection. Anomaly detection is a machine learning based techniques. It analyzes data over time and it detects unusual changes, if there's any unusual changes. Let's say, for example, now, imagine you are creating a software system to monitor credit card transactions. So the system will be able to detect unusual changes. In what sense? Let's say the customer used to withdraw 10,000 maximum in a month. So the first month that the customer tried to withdraw 1 million, then the system will detect like, oh, this is unusual. Then it's going to pull some triggers based on how the system is being designed. There will be some certain relaxation for the unusual action. Let's say, for example, now the customer used to withdraw 10,000. The first time the customer withdraw 15,000, 20,000, the system may still be like, okay, this is still manageable. But once it goes to 1 million, someone that never withdraw 20,000 before, then the system will detect that as unusual changes. The example I have here with me for this vehicle driving, you see the first one, the second one, the vehicle was going very smoothly, but the third one, there's a kind of delay. Then the system will know this delay is unusual changes. Then it's going to put some triggers. It's going to notify the appropriate developers or the appropriate authorities as the system is designed. So that's basically the anomaly detection. Computer vision. So the computer vision is part of AI that involves visual processing, obviously. A typical example of this is the Scene AI application. I don't know, has anybody used Scene AI before, the app? Has anybody used Scene AI before? Okay, no. Okay.
Repeat your question, please.
Has anybody used Seeing AI? This application, Seeing AI, is an app by Microsoft. Let me
No,
just.
no.
Okay, no. Okay. You should try it out after this event. It's such an amazing application. So the Seeing AI is example of computer vision. It's designed for the blind and low vision community. So the Seeing AI app, it harnesses the power of AI to open the visual world and describe nearby people, the text and object. So it can actually show what's going on, what's there, and the likes. So that's Seeing AI. It was the Seeing AI was there in the first video I show. So the Jane, the girl, was using the Seeing AI. Anybody that joined early would have that experience. But let's just move on. We can explore that later during the demo session. So this is the branches of computer vision. We have the semantic segmentation. That is an advanced machine learning techniques in which the individual pixel in the image are classified according to the objects in which they belong. So that's the semantic segmentation. The object detection, the machine learning models are trained to classify individual objects within an image and identify their location with a bounding box. This is the bounding box, this rectangle. So that's the bounding box. That's for object detection, to detect objects and their picture. Then we have this image analysis. So the image analysis basically gives the description of an image, like a person with a dog on the street. This description was generated by artificial intelligence. Like the description was not written by a human being. The system analyzes the picture, sees what's going on the picture, and gives a description. At times we may have more than one description, but the system will give them in the hierarchy of which one is better, which one is better. We have the OCR, which is used to detect and read text in an images, like you say, like this bank now. Then the image classification, it involves training the model to classify images based on their contents. The last one, which I think most of us must have been familiar with, is the face detection. We must have seen it in those videos we watch for image detection tool. It's a specialized form of object detection that locates human faces in an images. So maybe on the street now, it can identify the face of human. Okay, the time is actually against us. So NLP, natural language processing, so that's used to interpret written or spoken language. That's what NLP is used for. We see this other things we can use NLP for. We can use it to analyze and interpret text in document, images, text, and others. Then the last one from the AI element, which is conversational AI. Conversational AI, most probably most of us must have maybe directly or indirectly interact with it. Is AI agents participate in conversation with humans? A typical example is the bot. We all know bots. When we open a commercial website now, you want to order or you want to do something, most of the time the bot will be the one to come forward. You will chat with the bot, and you can actually use it to lodge your complaint. You can use it to make, even you can use it to make order, you can use it to make some reservations and the likes. So that's conversational AI, the bot. This is like a start of the bot we have. We're having like over 30 million messages per day. Is there over 30 million messages per day on bot? So the bot is a typical example of conversational AI. So that's the basics of artificial intelligence and its key elements. Now, let's say, how do we get started with artificial intelligence? How do we start our career as artificial intelligence? How do we apply artificial intelligence in our field? Maybe I'm a medical doctor, maybe I'm a botanist. So how do we apply those things in our field? Microsoft has these cognitive services whereby there may be like little or no coding, and you can get your model. They have pre-trained models. They have pre-trained models in the system whereby users can just explore, and after explore the pre-trained model, they can modify it to their own taste. Let's quickly go through it because I think I have 5 minutes left. So these services we have the Azure Machine Learning Service. So Azure Machine Learning Service is a cloud-based platform for creating, managing, and publishing machine learning models. So there are pre-trained models there. So you just have to go there. Then you have to modify it to your taste. There is options for professionals, like if you can write the codes, or if you cannot make the codes, like there are automated models, pre-trained models there, whereby you can use to make your own models. We have the anomaly detector service. So it's an API. It's an application programming interface that developers can use to create anomaly detection solutions. We have the computer visions, we have the custom vision, the face, form recognizer, and the likes. Let's quickly run through the demo and we move to question and answer. I have only 3 minutes left. So let's do the demo of AI. Before we go to the demo, let me show us something. Okay, my screen is visible. Is my screen visible now?
Yes.
Okay.
Yes, sir.
So this is what a model looks like. This is actually in Python. This is a Python script model. So this is what a model looks like if you want to make the code. But as we said earlier and as we promised, today is not going to be for professionals alone. It's going to be for everybody. Next time we are organizing another event only for professionals, then we'll be looking into coding. So this is what a model looks like. This is in Python. We can make the model in R language also. So I just want to show us this. But instead of making this model, let me see this. This is another kind of script. It's not working. So this is just a word cloud script you can use. But instead of writing the codes, if you are not a professional or you are not looking into making the codes, then there are cognitive services which enables you to make your models without writing a code. Let's say this text analytics. Let's try to use this. Okay, I think this is a customer review I copied from the internet. Let's try to analyze this text without writing a single code and see what we can get. This text analytics is part of the services for under NLP. So this is a text now. Let's try to analyze it. Let's see what we get. It's still loading. It's still loading. Okay. So this text is giving sentiment of 90%. That's 0.9. In artificial intelligence, in machine learning, basically, we have this the rating from 0 to 1, 1 being the most positive and 0 being the most negative. So this customer review, the best coffee place in Amsterdam, super friendly, all this place. So the system is telling us, like, if we analyze this text, it's giving us 90%. That's the sentiment of this text is more of positive side. Let's try to analyze it further. What are the key phrases in this review? We have the coffee, we have the super. If we click on this, it's going to give us a Wikipedia article like this now. It's going to give us a Wikipedia article of the entities, of the key phrases. Now let's check the entity linking. So these are the entities in the customer review, coffee, Amsterdam, super one. So if you have a business, now and you get some customer review, then you can actually use this demo model to analyze what the customer is trying to say. Is it more of positive side or negative side? Let's quickly edit something now. Not the best coffee place in Amsterdam. Let's analyze this and see what we get. It should be negative, obviously. Yeah, this is 15%. That's 0.15. So this, because of the not, not the best coffee place in Amsterdam. So this is giving sentiment of a negative. So this is a model. This is an artificial intelligence model whereby you can use without even writing a single code. Let's explore only one model more before we go. This is a LUIS language understanding service. Let's see what we can do with it. This LUIS system, it understands spoken language or written, but I'll be using only the text because to avoid the interference. Let's say this system now, I say on the lights. So it's going to on the light. Let's say I'm expecting guests. Yeah. So this is how this whole thing works. The system, that's how it works for this model. So you don't literally need to write any code if you are not a professional, and that doesn't give any disadvantage to developers because there is options for developers for professionals to make codes. But as a non-professional, you can easily deploy your models without writing a single code. So now let's move to question and answer. Before I transfer the control, does anybody have any question on this? Any question?
You take my question, please.
Okay.
Hello.
So, hello?
Yeah, sorry. Can you please go to the overview slide?
The overview, okay.
Yeah.
Yeah, okay. The first question, difference between AI and ML. Okay, I'm coming to that. Do I need to learn machine learning before AI? Okay.
The last bullet there.
Before, yeah. The last bullet, yeah. The last bullet from the overview, yeah. I'm coming to these two questions, but let me answer this first. The last bullet, yes.
I also have a question.
Please
so
wait.
You said journey for graduate.
Yeah.
Hello.
Hello.
Yeah. So the journey for content. I don't know. Maybe you can just take us.
Yeah. We are still going there. We are still going there. I mean, joining of a graduate MLSA. We have a graduate MLSA that we discussed with us. She's going to share her journey with us. That's Sabia. So we are still coming to our session.
Okay.
So now let me
missed out.
Let me answer this question, please. Okay. How was semantic segmenting? Semantic segmenting. Semantic segmenting. Can I use bot on WhatsApp? Okay. Can I use bot on WhatsApp? Difference between AI and robotics. How does my field related to? Please, no more questions. Let's just take care of this question. How does my field related to AI? Anybody that has any other question can private chat me. I will just take care of this question, please. Okay, let me go with the first one now. What is the difference between what is the basic difference? The first question. Okay, basic difference between AI and ML. The difference between AI and ML is that ML is inside AI. Like artificial intelligence is part of AI. Artificial intelligence is part of AI. Then the second question.
Okay.
Do I need to learn machine learning before AI? Obviously, AI is like the mother. So for you to understand this, for you to understand the, I'm getting another question now. Do I need to learn ML? Okay, we take care of the rest of the question. Let's just take the one at hand. We ignore the rest of the question. So do I need to learn machine learning before AI? The machine learning, the AI generally, importance of AI in fashion industry. We won't be able to answer all the question. Okay, let's just continue. So do I need to learn ML before AI? The AI system is based on machine learning. So for you to fully understand the concept of how artificial intelligence work, you have to learn AI. So in short, you need ML before AI. So semantic segmentation. Semantic segmentation is, as I explained earlier, in the, okay, they say, okay, we answer all the question at the end after Usefa's presentation. That's Usefa's suggestion. Let me just write it down. Importance of AI in fashion industry. That's it. So we move to the next presentation, then we answer the question at the end. Thank you so much. Now we move to the second presentation by Usefa. So Usefa, now you can take control. Are you there?
Hello guys, can you hear my voice?
Yes, you are audible.
Thank you, Suleiman, for doing kind of great presentation about an overview of AI.
Yeah,
hello guys. Welcome to all of you. I'm glad to be here to present something related to AI and our next generation technology. Suleiman did a great job about introducing a short overview, a quick overview to artificial intelligence, and we all believe that artificial intelligence is our future. But the problem is that artificial intelligence is, we mean data. We have intelligent architectures, we have intelligent artificials if we have a lot of data or compute the data as we have. But we have a problem now dealing with intelligent architectures. We all know that that architectures, computers, the devices we have today is composed of hardware and software. We have a pretty good intelligent software, but the problem is that software is giving with the hardware. So we should have an intelligent hardware compatible with the intelligent software we are using today. We all know the computing we have, every computing is bottlenecked by data. So we should compute data. And data is key for today's technologies, machine learning, AI, genomics, and everything we have around us. Every important workloads are all data intensive. Sorry, I'm kind of going quick because we have a lot to discover and we have less time. So also we need to get an intelligent architecture is a rapid and efficient processing of the large amount of data we have, because every day data is increasing. Everything around us is just data overwhelming, and data is, we mean when we get data, we should have a good performance and energy bottleneck. The data we are processing should be kind of efficient and rapid computing, and we should have an energy sufficient using in the data that we are computing every day. Why? Because today we have great architectures, we have great processors, CPUs. What was
Hello?
happening?
Okay.
Can you share the presentation? Sorry.
Yeah, let me share it. I thought you have the control. Let me share it again then.
Someone kicked me out. I don't know.
Okay, fine. I took it back. I will give it to you now.
Okay, thank you.
Yeah,
Sorry,
you have
guys.
You have it back.
Okay, thank you. Hello, who's kicking me out? I don't know.
Don't worry. I have the control now.
Okay. Give me the control, please.
Okay, you have it now.
Sorry for what happened. Data is key for future workloads. What you see in the screen is the processing of genomics we have. Main point in healthcare today is just DNA sequencing. In 2014, we just could sequence 229,000 of DNAs in human body, which human body have millions or billions of DNA. In 2017, we increased the sequencing of DNA to 1,620,000 because of the improving of the architecture of the device you're using in DNA sequencing. What is DNA sequencing composed for? What this? Our job as a technician, as IT, is with a machine
Hello,
that
Abuki.
are sequencing and analyzing the
Good
data.
day, and you are
With
I moved the person.
Can you mute yourselves, guys?
I moved the person already. You can continue now.
Okay, thank you. So our main point is increasing the sequencing of DNA. Why? Because increasing the sequencing of DNA could cure the diseases we have. If we could sequence every details in the DNA of anything, virus, worms, humans, we can do anything. We can, for example, create vaccines for any kind of virus, including COVID-19. So how can we increase this? We increase this by creating an intelligent architecture. Data overwhelms modern machine. We have plenty of data today. We get from internet, from any device that we are using. But the problem is that we haven't computed every data we have. Most of the data, probably 80% of the data is unstructured and haven't computed yet. Modern machines have what? Have a storage and memory capability, communication capability, and computation capability. So these capabilities impacted the robustness, energy and performance, and cost of the machine we have. 62.7 of the total system energy is spent on data movement, and we all know the energy we have is limited, but 62% of the data of the energy we have is spent on total movement. A total system energy is spent on data movement. We say computation machine, so it must compute, not just moving data, which should be more than 60% of the total system energy must spend on data processing, not data moving. But unfortunately, today's architecture is not like that. What's a computing system? We all use computers, mobile phone, smart devices we have today. The computing system has three capabilities: computation, communication, storage, and memory. We get data from input devices, we process them, we store or we output this data. This is what a computation system do. But let's see a small part of the architectures we have now. The architectures we have is process-centric. Everything should go through a process, and after that for other parts of the computing system we have. The image you are seeing is a process image. You can see most of the parts of this processor is for data movement. All the cache parts, shaded L3 cache parts, is just moving data. They are storing and moving data for the process, core 1 till core 9. We have a small part that processing data. All the parts we have is just moving data, which we say a computation machine. So it must compute data in every place, not just moving data and compute in one place. So what's our axiom? What's our point? Why we are talking about that? We are saying we should have an intelligent architecture to handle data well. We say we are going to an intelligent era, and we have a lot of data. So we should have an architecture to handle data well. We all know we cannot do anything with software if we don't have a good hardware for it. So what's the perils of process-centric architectures? The perils of today's architecture. What's the problem? The problem is they are imbalances system. Why? Because the computation, the process, we said, is just doing in one place. Is done in one place. We said it should be in variety places. We have process, and everything else just stores and move data. Every device you see except processors, they are just storing and moving data. They don't do anything. So it's energy insufficient. We have low performance, high latency, and we have a complex architecture. And overly complex and bloated processors. We have a complex and bloated processors. It's too detailed. We don't go into how processors made and how it's complex, how much complex. And this is make an energy insufficient, low performance, and complex architectures. So how can we handle data well? We are saying we should handle data well to get an intelligent architecture and intelligent hardware. We must ensure data does not overwhelm the components. We must ensure that that does not overwhelms the components. How we can ensure that? Via intelligent algorithms, we should create an intelligent algorithms and intelligent architectures that we are speaking lately. And via the whole system design, we have intelligent architecture, intelligent algorithm and intelligent architecture. So these two parts should compatible with each other to create an intelligent system design. And we can handle data well if we take advantage of vast amount of data and metadata. This improves architectural system level design decisions. If we take the advantage of the data that the hardware accepts and moves and process, if it can identify and it can get benefit from this data, so we can create an intelligent architecture. We all know the intelligent softwares today we have. They are taking benefit from the data they take, and after that they create high-level decision, high-level intelligent decision. And the architectures should understand and exploit the properties of different data. The architectures we have must categorize the data comes to them, so we can improve algorithms and architectures via various metrics. Architectures. Today's architecture, we said, they are terrible at dealing with data. Why? Because they are mainly designed to store and move data instead of computing data. They are process-centric, opposite to data-centric. And they are terrible of taking advantage of vast amount of data and metadata. So this makes human-driven decision vs data-driven decision. And they are designed to make simple decisions. They are ignoring the loss of data they are accepting, moving, and processing daily. So they are just make a simple decision designed. Architectures are terrible at knowing and exploiting different properties of data. The today's architecture we said they are component-aware decision. They are aware of the components they have. They are not data aware. They don't know what's the data and what's the use of data. How can they use the data to improve themselves? They are component-aware, and they treat all the data as the same. We know that data are different. They are various, but they treat all as the same. So how can we achieve a data-centric, memory-centric architectures? When we say data-centric, we mean memory-centric. Why? Because the data we have stored in memory. So we should create a memory-centric architecture. We can make a architecture, intelligent architecture in different ways, but due to low time, quickly we just talk about one of them, and it's process data where it resides. We should process data where it resides, where it makes sense. When we have data, why we have data in memory and process it in processor? Why we don't process in the just memory? So we should process data where it resides. So it means processing in or near. So, and we low latency and low energy data access. We should create a low energy latency and low energy data access. And after that, low cost data storage and processing. If we take the energy that we are using in the memory movement, in the data movements, we create a low latency and low energy memory, and also we get a high capacity memory at low cost, hybrid memory and compression. And we can do intelligent data management, intelligent controller handling, robustness, security computer. We have some intelligent controllers near memory, which we can use to improve memory decision and memory computation. How can we create or process data where it resides? We can process data where it resides, where it belongs in memory. But before that, why we are talking about in memory computation today? Why we have memory computation today? Why we don't talk about in past? We have there are some papers that they talk about memory computation, but it's not much. And we have the facilities, the factories, they don't think about that. We have a push from technology. We have a DRAM scaling, which is a great issue, a lot of issue for architectures today. And we have some controllers close to DRAM that we can use as intelligent controller, as we talked about previously. And we have industry open to new memory architecture. We have great places that we can use this places architectures to create an intelligent architectures. And we have a pull from system and applications. We have data access in major system application bottleneck. We have a lot of system, a lot of softwares that we can use their data to create a high intelligent architecture. We have systems are energy limited. The system we have, we said they are energy limited. We cannot use a lot of energy. So we have a limited power of using energy. So we should use this energy in processing data, not moving data. Data movement is much more energy hunger than computation. We can the amount of energy we are using, the amount of energy we are using in data movement. If we use in computing data, we get a lot of intelligent architectures. We get a lot of intelligent decisions in our hardware. What's the challenge and opportunity for future? Creating a high performance, energy efficient, and sustainable architectures. The problem is processing of data is performed far away from the data. How? This is the design of modern computing systems now. They are all overwhelming by process centric. Everything is going through processor. All data processed in processor. We have just everything in processor, and data storage units are dumped. The other parts, the storage parts of data, they are dumped. They are just sending data and receiving data. They cannot categorize the data. They cannot take advantage of the data they have, and they don't have anything. They just moving data in or out. Why they are dumb? Why we are telling the memories are dumb? Because as you see in the image, most of the time we have is non-stall computing time in data. The architectures today we have, they waste a lot of time. They have a high latency, just they are waiting for data to be processed in the processor. So this is a lot of issues that we are facing today, as you see. And this is a Google's data center workload. You can go after that and see that a lot of times we have in the things, for example, indexing, searching, they are just waiting for data. They are not computing data. As we said, see 2.7 of total system energy spent of data movement. If we use this in data computing, we can create a high intelligent architecture. What is the purpose, or what is the design of a data-centric architecture? Instead of sending data, we send query. We ask processor to send to receive query from processor. So we send query to from processor to memory, and we get results from memory to processor. This is all we can do to get a high intelligent architectures, because we know that queries are much more faster, and they don't need a lot of energy to move. The goal is processed inside memory. This is the architecture of a computer, from software to hardware, problem to electrons. Electrons tell microarchitectures about hardware, system software to problem is just about software. Our part is from the things that we need to shift to get a high intelligent architecture. It's from algorithm until logics, sometimes to devices. We should edit all of them to get a highly intelligent architecture. We should have a great algorithms, intelligent algorithms, and we should have programs and language that compatible with the new memory we are using, and system softwares, and also interfaces and macro architectures. Processing in memory have to approach creating a minimally changing memory chips. We need a small change in memory chips, and exploiting 3D stacked memory. We don't speak about exploiting 3D stacked memory. Our last part is how to minimally change a memory chips to be intelligent. DRAM has a great capability. The DRAM we have today has a great capability to perform bulk data movement and computation. We are talking how that they can exploit internal connectivity to move data and exploit analog computation capability. We have a row clone as example. You can read about row clone in this international papers that I have mentioned in the slides. They are all international, and they publish it in different journals that you can read about row clone, how is that and how we can get it. And row clone, we can make operations like AND or gather, search, or move, copy just in memory. We don't need to go through what we have today through memory. This is a DRAM cell operation. It's not important for now. Today's system, bulk of data copy. This is a data copy of today's system. We firstly, we have two different datas in memory. when we send this data to cache, and after that the others to cache, and we copy in cache after that for CPU, and we copy in CPU, and we send back to what we have with memory. So this is make a high latency and high bandwidth utilization, unwanted data movement, and cache pollution. For this operation, we need 1046 nanosecond and 3.6 picojoule for just 1 kilobyte page copy of VRAM. The architectures that we are proposing now doing the same operation by what? If we just do the same operation, this is the previous image, sorry, I haven't edited that, but we can just process inside memory, and we have a low latency and low bandwidth utilization and no unwanted data movement, and we don't have any cache pollution. We can perform the same operation by just decreasing the time to 19 nanosecond and decreasing the energy we are using to 0.04 picojoule. This is a lot of energy and time we are getting by just processing inside memory. This is what we mean about row clone. Copying a row. For example, we will activate row A, and after that we activate row B. We send row A to row buffer, that's just for copying and or something like that. And after that, we send the data we have in the row buffer to row 2 to activate row B. So we have copied the whole row in row A to row B inside memory, and we didn't need to process it, to move it to cache, and after that to process and processing inside it, and after that returning to memory. This is also an international paper you can read about it, row clone. We have some in-memory bulk bitwise operations we can do with the architecture we are proposing now, which is copy, 0, and or not, and the other operations. And this operation that we can do is not less, because most of the queries, the movement of data today is for this 4 or 5 we can say actions we are using now. This is the operations that we can use with bitwise operations. We can use database indexing, and we can use database querying, web search, DNA sequence mapping, encryption algorithms, and set operations. And also to have some pros and cons. Thank you for listening to my presentation. I'm glad to just share some knowledge about creating an intelligent architecture for intelligent machine, and this is all what I was proposing. Thank you.
Okay, thank you, Usiva. I think we should take the question at the end. We take the question together. Let's quickly run the other slides, and we can take the question at the end as the last thing. Is that okay?
That's okay.
Yeah, please send your question to the chat bot, and whoever can note them down and can provide answer at the end. I already have answer to my own questions. So the next one, thank you guys for bearing with us. I think we are now running over time. So joining the MLSA program. So who are we at Microsoft Learn Student Ambassador? So we are a global group of on-campus ambassadors who are eager to help other students and their communities and lead in their cycle and develop technical and career skills. This is our global community. Currently, we are having 4,700 students across 1,200 plus universities in 102 countries. India is obviously leading with 1911 students. Nigeria is having around 124 students, and we have students across the globe. So this is our global community. Now, how to join us, how to apply. On a quick notice, to apply, this is the link to apply for Microsoft Learn Student Ambassadors. You can note the link down, or you can message me after this event. I will surely send you the link. But it's not about apply alone. What does it mean to be an MLSA? If you are an MLSA, it means you'll be supported while you build your community, while you make a difference, while you lead others, while you learn, and while you share your knowledge. So Microsoft is there to support you while you do all these things, while you build, while you make difference in your community. And you will get access to a lot of tools from Microsoft that will help you in this. But it's not about the benefits alone. It's not about getting the subscription, getting the swags, getting this. It's about ready to make a difference. It's about having the charisma to give back to the community. So who can apply? Okay, let's quickly run that. For you to apply, let me move to this. Who is this? For you to apply, you must be 16 years old. So 16 years old, have a valid ID card, and actively enrolled in an accredited higher education institution, maybe university, maybe polytechnics, maybe college. So it's open for everybody to apply. No, just as a student, 16 years old, and you have this special. Who is this? Please, let's mute ourselves. So that's the basic criteria to apply, but it goes beyond that. You must have displayed some set of leadership roles. You must have some experience, but it's not about coding experience. You may not have coding experience. You may not be technical, but you must be like hello, who is there? So you may not have the coding experience, you may not come from technical background. So there are a lot of tools to help you learn during the program. So what are the benefits you will get? The benefits include, but not limited to this. So you will get access to Microsoft 365 Plus and other software free of charge from Microsoft. You will get Visual Studio Enterprise subscription and 150 USD monthly Azure credits. You get exam certification vouchers, LinkedIn Learning, and lots more. So these are the basic things you will get. But apart from that, we get access to this global community of pool of students from different backgrounds, from different communities, whereby you can interact, you can collaborate, and you can grow together. So still, we take the question and answer at the end. So making the third Q&A we take. Let me quickly hand over to Sabia to run a slideshow. Sabia, are you there? I'm not sure.
Yes, can you hear me?
Yes, I can hear you.
All right, great. Thank you, Suleiman, for the great presentation. I tuned in a few minutes and I saw Huzaifa and Suleiman give a very nice introduction to the program. Yeah. So I guess this part would just be me sharing a little bit about my experiences in this student partner program. So Suleiman invited me to just give a few minutes talk about how it's been for me in the program. So if you don't mind, would you? Yeah, thank you. So basically, I am a recent computer science graduate. I was a part of the Microsoft Student Learn Ambassador program since 2 years now, and I just left it in March 2021 as I graduated. And honestly, this program, if I could say, would be the best thing you could sign up for during your time as a student, because you get access to like technical skills, you get access to event organization skills, all of this which you develop through actually conducting events and interacting with people across the world. Personally, when I joined the program, I was not very aware of a lot of these event organization skills because I was more focused on technical aspects. So having the resources such as LinkedIn Learning and the resources from the Microsoft employees, they give like presentations and they hold like weekly office hours. So all of this really helped build like how do you actually conduct an event. And in that way, I was able to conduct events for my community in the UAE. So overall, I would say that if you're really interested in giving back to the community and technical skills, I think you should definitely check out the link to the website and begin collecting material for your application. And it's not just the skills that you gain, it's
I think Sabia lost our connection. I think so. Hopefully she's going to join back soon. Yeah. Let me check. Do we have this question on the... While we wait for her, let's send our question on intelligent system so that we can run it together.
Hi, can you hear me?
Okay, welcome back. Welcome back.
Yeah, looks like it just said someone removed me from the meeting, so I'm not sure why it did that, but I'll just go continue forward. So yeah, so I was just saying that with apart from the LinkedIn Learning and all the different swags you get access to, you also get a lot of opportunities. So personally in the program, I had the opportunity to speak at the student zone of Microsoft Build, which if you have come across, it's pretty much the largest technology event where there's speakers, all Microsoft employees and different topics. So if you're doing well in the program, you're working to build your community, you do get access to these opportunities, which if the Microsoft employees and the program managers in the program feel that you're qualified for, they would invite you to speak at these events. So it's definitely a place where you could develop yourself a lot. And I would definitely recommend that you apply to it. And if you have any questions in terms of how to apply, I'm sure Huzaifa, Suleiman, or even I could help you out with the, like, what exactly should you put in your application, or we could direct you to a few videos on how to actually apply to the program. So I think that would be all from my end. And if you have any questions, feel free to send them in the chat, or you can just ask here as well.
Okay, thank you, Sabia. Thank you for taking time out from your busy schedule. Let's start with Sabia's question. Anybody that have question for her so that we may release her if she want to go, and we can continue with the rest of the question quickly. While we wait for that, let me continue with the questions I have here. Do I need to learn machine learning before AI? Yes, you need to learn machine learning before AI because machine learning forms the basics of AI. If you learn AI before machine learning, you will get lost. So the semantic segmentation, what does it mean? It means to label each picture according to what they represent. Let's say in a street now there is a dog, there is a car. So semantic segmentation is to label dogs, label car, label everything separately. So that's semantic segmentation. Another question: can I use chatbot on WhatsApp? Yes, you can use chatbot on WhatsApp, but Microsoft Cognitive Services does not support this this WhatsApp, as far as I know, but you can still use it. AI and robotics. Do I answer your questions? I'm not sure those that asked the question are still in the meeting anyway.
We are here. We are here.
Okay. So AI and robotics. Let me see, maybe I can show you something from my screen. So this is I have a picture here. Okay. Okay, let me quickly share you this picture. This is robotics and artificial intelligence. So it's kind of two separate things, but they are intertwined together. Like the two of them, they work hand in hand, but they are not inside each other. So that's the basic difference between AI and robotics. AI is used to improve robotics. Robotics is more or less like the hardware we see. But when we're talking about artificial intelligence, the machine learning, it can be software, like the software models built. But most of the time, the software models built is on artificial intelligence is used to power the robotics hardware. So that's the difference between AI and robotics. How do the next question? Let me move to the next question. Importance of AI in fashion industry. Fashion industry, like other fields too, let's say any business. So you can use AI to identify your customers' feedback. You can, like we just did this text analytics. So you can analyze the text of your customers review, your customers' feedback. You can see what they are saying, then you can use it to serve them better. But apart from that, you can use AI model to predict the products that sells faster. Like if you make 2-3 set of clothes as a fashion designer, so you can use AI model to predict which of the products sells faster. And in the future, you can work on producing more of those products, and that will improve your productivity. So that's one of the ways you can use artificial intelligence in fashion industry and other industry. Another question: how do I use AI in AI and chemistry? How does they relate? Yes, they relate together. These days, scientists, or let me narrow it down to chemists, they use artificial intelligence to discover more drugs at a very low cost and more effective. Like these days now, we are having COVID-19. So they are using artificial intelligence to run the development of the vaccines. So that's one of the uses of artificial intelligence in the chemistry. So they use it to make prediction, to make drugs very fast and more effective and at a very low cost. Another question: how does AI, machine learning, deep learning differ from each other? Okay, thank you. Obviously, you arrange them in the order. Deep learning is inside machine learning. Machine learning is inside AI. So that's how they relate together. Deep learning is a branch of machine learning. Then machine learning is a branch of artificial intelligence. The last question which I see here: can AI lead to lack of human-based jobs? Everybody asks this question, like from time to time, like not only AI, is the technology advancement going to lead to lack of human jobs? It's not going to be like that. It's going to be it's going to be like the technology is moving, the world is moving. Anybody that moved with the latest trend will never lose a job. These machines, they cannot work on their own at the long run. They still need human. But which type of human do they need? They need human that are expert in that particular field. When a data scientist want to predict, want to make a model to predict different type of flowers, a data scientist or an AI engineer cannot do that alone. It still needs a botanist. If they want to use AI to make vaccine, so they still need chemists. They need scientists in that field who is going to work with them. So AI is not going to take our job, but it's going to be like going to take people that upgrade themselves, people that try to move on with the latest trends. So that's why in every field we are, we need to update ourselves with the latest trend. I think that's all question on AI. Do we have any question on the? Okay, intelligent architecture. That's number one. Usaifa, are you there?
Yes.
Yeah, you have a question here. I think only one question. You can answer it and we can call it a day. The question says,
Okay.
I need more insights. Yeah.
I can see. Before that, I want to answer the question that how can intelligent architectures lead to lack human-based jobs? In my opinion, and what I see, recently we have participated in a webinar in Microsoft that it mentioned that AIs, just removing nearly 70 million jobs in 5 years, but it provides 135 million new job opportunities. So it does not remove every job, but it leads for removing the automation, the jobs that today we can do with automations, things that are daily routine, they don't have creativity. So if you are in a job with creativity, of human creativity, so I think that jobs will never remove by AI. And a light in intelligent architectures. As we mentioned, we have a pretty good architectures today, but the problem with the architectures of computer hardware today, they are not more intelligent, they are not data aware intelligent. They are data and process aware architectures. How? Because everything we have, it process inside processor. Every other components we have in computer, caches, level 1 cache, level 2, level 3, memory, and everything, input and output, they are just moving data. They are dumb. They cannot categorize the data they have. They cannot take advantage from the vast amount of data they get daily or every time. So they are dumb. They just move data. So the point is that to create an architecture that process inside the place that we have data. We have data in memory, so we should process inside memory. So this is the purpose of creating intelligent architecture. Why this lead to using sufficient energy? We have a low latency, and they are all sustainable, the architecture, if we process data inside memory. This is all we have.
Yeah, thank you.
Thank you.
The next question. I think. Yeah, I think you've. Someone said you need more insight on the architecture. I think that's all. Hello?
What?
Someone said you need more insight on. I think you've answered that question. You need more insight on computer architecture. I can say that.
You
on
can share
intelligent architecture. Yeah.
You can share the presentation later. I have provided some great journals, great high academic papers, so they can read them and they understand the idea of creating a high intelligent architecture.
The last question: can you make Python? Can you use AI in MATLAB? Yes, you can use Python programming in MATLAB. So I think we've answered all the questions. Do we have any other question? Yeah, I guess no. So we'll be rounding up the meeting. Thank you so much, everybody, for attending. Thank you, Usiva. Thank you, Sabia, for your nice presentation and taking your time out. So we really appreciate you. And to our audience too, we really appreciate you. We appreciate your effort. And be sure we are going to be having more webinar, but this time is going to be more specific. We'll be having for professionals separately and non-professionals separately to avoid this kind of brief presentation. So thank you so much.
Thank you, Suleiman, for having me as a presenter. Thank you, everyone, for attending.
Please, everybody, can you turn on your video if you can? Let's take a screenshot and see so that we can upload it on our LinkedIn and other profile. Please, just 1 minute, we take a screenshot. Turn on your video. Everybody, turn on your video. Let's take a screenshot. Yeah. So I'm taking the screenshots. Do we have more people on ground? I'm having like 6 now. Yeah. Thank you so much. I think we are done with this. So we have this picture. I will send it to us, and we can upload it on our LinkedIn or any place we want to upload it as the event. Yeah. So thank you. Now we can leave the meeting.